Okay, we are given a power series here, and we're supposed to find the radius of convergence for the power series. So you remember the way we approach these is to use the ratio test, knowing that when you take the ratio of successive terms, a sub n plus 1 over a sub n, when you take the limit as n goes to infinity of the absolute value of that, it only converges if that limit is less than 1. So we are going to find what x values make that limit less than 1. So I'll start by writing this down. So we start with the ratio test. So it says take the limit as n goes to infinity of the ratio of a sub n plus 1 over a sub n. And we have to figure out what values of x will make this limit be less than 1. So this is the limit as n goes to infinity of a sub n plus 1. So we go up to what our terms look like. And I'm going to replace all the n's with n plus 1s. So this is going to be x minus 3 to the n plus 1 over n plus 1. And then that's going to be all over a sub n, which is just the generic term x minus 3 to the n over n. Now we're going to simplify this and figure out what values of x will make that limit less than 1, because that's when the series will converge. So instead of division, I'm going to flip and multiply. Okay. And then I'm going to reduce x minus 3 to the n plus 1 over x minus 3 to the n. All of them will cancel except for 1 in the numerator. So these two cancel, leaving me with just a single x minus 3. And that's the only canceling that happens in this particular problem. So I have the limit as n goes to infinity. I'm going to take the x minus 3 out of the limit. So it's going to be the absolute value of x minus 3 times the absolute value of n over n plus 1. And in the limit, I can pull the x minus 3 outside of the limit. So this is the absolute value of x minus 3 times the limit as n goes to infinity of n over n plus 1. And then the limit as n goes to infinity of n over n plus 1 is 1, because they have the same degree. The leading coefficients are 1, so 1 over 1 is 1. So this is just the absolute value of x minus 3. So that is what the ratio test results in after we've done all of our simplifying. But the ratio test says that this series will only converge if this limit that we just calculated is less than 1. So I have to force that to be less than 1. Figure out what x's will make that true. So remember, when you have an absolute value less than 1, that translates to a sandwich, a -1 less than x minus 3 less than 1. X minus 3 has to be between -1 and 1 for its absolute value to be less than 1. Add 3 to all 3 pieces of this compound inequality, and you get 2 is less than x is less than 4. So that's our interval of convergence, but without checking the endpoints. That's an open interval of convergence. So if I just sketch that on a number line, here's a 2, here's a 4, which means my center is at 3, which means that the radius of convergence is 1. Okay, so I found the radius of convergence. To find the interval of convergence, I'm almost done with it. It's definitely 2 to 4. I just don't know if I should include the 2 or the 4. So I'm going to put 2 less than x less than 4. Include 2 or 4 is what we're trying to figure out. So we check x equals 2 by just plugging it into the original series. So my original series was x minus 3 to the n over n from n equals 1 to infinity. I'm going to put in a 2 for x now. So if you replace the x with a 2, we get the sum. 2 minus 3 is negative 1, so I have negative 1 to the n over n. This is an alternating harmonic series. The terms are decreasing towards 0 and alternating in sign, which means it converges by the alternating series test. So we're going to include the 2. So I put an or equal sign on the 2. Now if I put in a 4 for x, I get the sum from n equals 1 to infinity. 4 minus 3 is 1, so I get 1 to the n, which is 1 over n. 1 over n is the harmonic series, which we know diverges. So that means do not include the 4. So my final interval of convergence is this. X is between 2 and 4, including the 2, but not the 4.